Yes, students, in this session we'll discuss about the LR0 and SLR parsing techniques. So now in this session we'll be discussing about LR0 and SLR. So we'll be given with a grammar like this. So write LR0 and SLR parsing table for the given grammar. So the grammar is like A and A derives A and A derives B. Now once you have a grammar, you have to convert that grammar into augmented grammar. So how to convert that grammar into augmented grammar? You have to put one new production that is called as S dash derives S. So here S dash is a start symbol and S was the earlier start symbol. Now S dash derives S is the augmented production which has been added to that. So remaining three productions are same as it was earlier. Okay, so now you have to add one augmented production for this grammar in order to make this as augmented. So you now it is augmented grammar. So it is having a new production S dash derives S and it is having another remaining productions are as usual. Okay, so now like this you have to convert the grammar into augmented grammar and then you have to start solving the problem. So now we should give the production numbers for all these productions. So first production number is 0, another production number is 1, this production A derives A is production number 2, A derives B is production number 3. So I will tell you why you have taken these production numbers, and also we have to find a follow of as well as follow of A. So follow of A is equal to A comma B comma dollar and follow of S is equal to dollar. Okay, and so I have described how to find a first and follow in the previous video. So just go to the description box to get a link of it and you can see that if you want. Now the thing is, what we have done here, we have computed the follow of S and A and we have numbered the productions and then we have converted the given grammar into augmented grammar. So in the augmented grammar, we have one production which has been added, so that is S dash derives S. So now we have to construct a DFA for this, whatever the grammar we have done. In this DFA, what you have to do is, you have to take up a production, that production, augmented production, initially what it was there, S dash derives S. So you have to take up that production and you have to put a dot in the beginning of the RHS. Okay, so when you put a dot in the beginning of the RHS, what happened here? Here, next to dot, there is a variable that is S. So again, you have to write the productions of S with a dot in the beginning of the RHS. Because of this S which is next to this dot, you have to write the productions of S with a dot in the beginning of the RHS. So I have written the productions of with a dot in the beginning of the RHS. Again, you can see that there is a variable next to this dot. So again, I have to write the productions of A with a dot in the beginning of the RHS. Okay, I have written two productions of A with a dot in the beginning of the RHS. Now, suppose see here, there is a terminal next to this dot, so no need to do anything. There is a terminal next to this dot, so no need to do anything. Now, this is called as closure. What you have done here, that you have taken the first production, you have put a dot in the beginning of the RHS. So again, you continue the same thing. When if there is a variable next to this dot, you have continued the same thing. So that is called as a closure. What you have done here is a closure. And one more thing you need to know about LR0 item. So there are two things. One is LR0 item, one is one item. So in this LR0 as well as SLR parsing techniques, you will be using LR0 items. Now this LR0 item means if you have dot in the anywhere at any position in the RHS of the production, for example here it is in the second position, here it is in the first position, here it is in the last position. If you have dot like this at any position in the RHS. This is called as a LR0 items. I will tell you what is LR1 item when I am going to discuss about CLR and LALR in the subsequent videos. Okay. So now please understand what is LR0 item. If there is a dot RHS of the production at any position, that is called as a LR0 item. Now we have done this, we have applied a closure for this, and next job is move this dot to the next position, that is called as a goto. See here, this dot is there before yes, and we have moved this dot to the next position, that is called as a goto. Now here we have written yes transition. See, there is a transition from I0 to I1, so the input symbol I have written yes. Why? Because next dot, that is yes is there, so we have to write yes here. Okay, and then after that we have to move this dot to the next position, that is called as a goto. So now you have understood three terms. One is closure, goto, and LR0 item. LR0 item, you have, if there is a dot at the RHS of the production at any position. Now closure means you have to write a production with a dot in the beginning of the RHS, and after that if there is a variable next to the dot, again write the productions of that variable with a dot in the beginning of the RHS. Again, if there is any variable next to the dot, you have to continue that. Okay, if there is a terminal, no need to do anything. Okay, that is called as a closure. So this dot, if you put to the next position with a transition like this, is called as a goto. Okay, so now three things you have understood now. Now this I0 is done. Now I0 is done. You have written the dot here in the yes, and you have written the productions of yes with the dot in the beginning of the RHS. Because of this A next to the dot, you have again written the productions of A with a dot in the beginning of the RHS. So now because of this terminal, no need to do anything next to the dot, and there is a terminal next to the dot, no need to do anything for this. Now you move this dot to the next position, and I have done that. The input symbol is yes for this transition. And now S dash derives yes dot. So here you can observe that dot is there at the end of the production rule. So this means that it is a final item. So I1 is a final item. State number I1 is a final item because dot is there at the end of the production rule. And also that this production rule belongs to the start symbol. Okay. Now I0 on capital A going to I2. So why on capital A it is going to I2? Next to the dot A is there. So because of this A, I am going to this I2, and here what I am doing, I am moving this dot to the next position. Dot is there here, I am moving this dot to the next position. So after that, suddenly you can see that next to this dot again one more variable is there, that is A. So I have written the productions of A with the dot in the beginning of the RHS. So what I have done, I moved this dot to the next position, I have written this. Okay, so next to this dot again one more variable is there. So because of that, I have written the productions of this variable, that is A. I have written the productions of A with the dot in the beginning of the RHS. Okay, now the next to this dot terminal is A, next to this dot terminal is A, so no need to. Now this dot you have to move to the next position. So I have moved that, this dot I have moved to the next position. Again you can see that next to dot there is a variable. So I have written the productions of that with the dot in the beginning of. Okay. So next to this dot there is a terminal, no need to do anything. Next to this dot there is a terminal, no need to do anything. Now we have to move this dot to the next position. So on B I am going to I4. So I have moved this dot to the next position. Now A derives B dot. So it is a final item because dot is there at the end of the production rule. So it is a final item. So next after that, on A I have gone to this state, and on small a I have gone to this I3. And now let us see here, this dot is still in the middle. Our intention is to make all the dots at the end of the production rule. That is what our intention. So why? Because when this dot A indicates that compiler has scanned this A and it has not scanned this A. Compiler has seen this first A, compiler has not seen this second A. That is the meaning of this. So here in this case, the before dot A is there. Okay, Compiler has seen entire things, that is A, both A's compiler has scanned and also seen. So that is the meaning of this, because in this case compiler has not seen this yes. In this case compiler has seen this yes. In this case compiler has seen first A and not second A. In this case compiler has seen first A as well as second A. Okay, so in this case compiler has seen this terminal A and not seen this capital A, not seen this variable A. In this case compiler has seen this terminal A as well as this variable A. Okay, so that is the meaning of the dot present in the production rule. So now this dot we have to move to the next position. So already we have moved that. So it is a final item. So it is everything is done with this. Okay. Next, after that we had to move this dot to the next position. What happens when you move this dot to the next position? When you move this dot to the next position, you will find another state which is similar to I3. You can see that what I have done here, the dot is in after A, and then after that what happened again, because of this variable next to dot, I have written the productions of A with a dot in the beginning of the RHS. Same thing will happen here also. If I move this dot to the next position, I'll get the same state as similar to I3. So I have made this transition from I2 to I3 on the input symbol A. Okay. So now on the input symbol B, so if I move this dot to the next position, I will get the same state similar to I4. So that is why on symbol B I am moving it, I am making a transition to I4 from I2. Okay. So now I3. If I move this dot to the next position, what happens? I will find this I6 state. So I am moving this dot to the next position. So because next to dot A is there, so that is why I have to write here. Okay. So now A derives A dot. Now if I move this dot to the next position, it will be similar to the same state I3. So that is why I have put a self loop on A. Okay. If I move this dot to the next position, I will get this state. So that is why on B I am going to I4. Okay. So now we have done with everything. We have taken care of this. We have taken care of this. This dot is moved to the next position. I got this. When I move this dot, I will be getting I3. So I have a transition. So when I move this dot, I will be getting I4. I have a transition here. When I move this dot, I will get I6. I have done this. This is a final item. When I move this dot, I will be having I3 only. So that is why self loop. When I move this dot, I will be getting I4. So everything we have taken care. It is a final item. It is a final item. When you call this as a final item, when the dot is there at the end of the production rule. Okay. So now I1 is a final item, I4 is a final item, I5 is a final item, and I6 is a final item. Okay. Now this completes the DFA. Now there are how many states? I0, I1, I2, I3, I4, I5, I6. So 7 states are there. So now this DFA is same for LR0 as well as SLR. Okay. Now this LR0 and SLR differs only in one step. What is that step? Let us see. Now see this I0 going to I1. So I0 row on S column I had to write just one. Okay. So now this table consists of two parts. One is action part, one is goto part. In the goto part you have to write a variables, and in the action part you have to write a terminals along with a dollar. Okay. So whenever it goes to variable, so you have to write just the number of the production, number of the state, and then whenever it goes to terminal you have to write, for example, I0 on A, it is going to I3. I have to write S3 here. Why? What is S means? S indicates shift operation. Okay. R indicates reduce operation. So this shift operation, reduce operation, you will see once you do the tracing for any of the strings, whether to check whether that string is accepted by LR0 or not. At that time you have to perform these operations. So you have, instead of 3 you have to write S3, instead of 3 you have to write R3 in case of this action part in this LR0. Okay. So now you can see that I0 on capital A going to I2. So I0 row A column I have to write 2. Okay. Next, I naught on small a going to I3. So I naught row, A column, I have to write, instead of 3, I have to write S3. Okay. So now S3 indicates shift operation. Right. Now I naught on B going to I4. So I naught row, B column, I have to write S4. And I1 is a final item belonging to start symbol. So in the dollar column I have to write except. Why write this except means whenever you do the tracing, when the end of the string is encountered, so if it reaches this place except, then the string is accepted, otherwise it is rejected. Okay, so that is the reason I have written except here. Now let us see I2. I2 on capital A going to I5. So I2 row, A column, I have written 5. Next, I2 on A going to I3. I2 on S3. I2 on B I4. I2 on B S4. I3 on capital A going to I6. So I3 on capital A going to I6, 6. I3 on small a going to I3 only, self loop. I3 on small a going to I3, so that is why S3 I have to write. So I3 on B going to I4. I3 on B going to I4. Now I4 and I5, I6 are final items. So you can see I4 and I5, I6 are the final items because dot is there at the end of the production in all the I4, I5, I6. Now in these rows you have to write a reduce operation. For the final item you have to write a reduce operations. So which reduce operation you have to write and where you have to write. For example, in I4 row, you have to write a reduce operation. Okay. In which column you have to write what? That let us see. Now I4, A derives B. What is the production number? You see, A derives T, B production number is 3. So you have to write R3. Now R3 in which column you have to write? In LR0, R3 you have to write in all the columns of the action part. All the columns of the action part. Action part means and dollar. These 3 columns belongs to action part. So I4, in the row I4, I have to write R3. Why R3? Because see this production. What is the production number? 3. That is why you have to write R3 in the I4 row in all the columns of the action part. Now I5. Let us see what is I5. I5 is S derives AA. S derives AA is what is the production number? 1. So R1 you have to write. R1 you have to write in all the columns of the action part. Okay, I6. I6 AA. What is the production number? A derives AA is a production number 2. So R2 you have to write in all the columns. Now this is about LR0. Now there is SLR table also. SLR table, it differs only with the way you write this reductions, reduce operations. Okay. So now in I4, I5, I6 you have written in all the columns of action part. Okay. Now but in case of SLR you have to do these things only in the follow of LHS. For example, I4, let us consider I4, A derives B. What is the production number? 3. So R3 you have to write in this LHS of the follow of LHS of this production. What is a LHS? A. What is follow of A? AB dollar. So R3 you have to write in AB dollar column. Okay, you can see that. This is SLR parsing. So R3 I am writing in the A column, B column and dollar column. Okay. Next let us see I5. What is I5? I5 production number S derives AA. S derives AA is a production number 1. So you have to write R1. Where you have to write R1? In the LH, in the follow of LH. The LHS in this production? Yes. What is the follow of? Yes, dollar. So you have to write R1 in the dollar column only. See, R1 is written only in the dollar column. Okay, let us see I6. I6 production number A derives AA. So production number is 2. R2 you have to write. Where you have to write? What is the LHS? A. What is the follow of LHS? B dollar. So R2 you have to write in the AB dollar column. So A column, B column and dollar column. Okay. So this is SLR. Construction of SLR parsing table, and this is construction of LR0 parsing table, and this is the DFA, and this is the augmented grammar and follow of S and A and the production numbering. Okay, so now like this you have to find a follow, like this you have to find the SLR parsing table. So only one difference with respect to LR as well as SLR. What is that is, you are writing the reduction, you are writing the reduce operation in all the columns of action part in the LR0, but in case of SLR you are writing the reduce operation only in the follow of the LHS. Okay, in the follow of you are writing the reduce operations. Okay.